Welcome to the Copperfield Electric Podcast. Imagine this. You are literally days away from closing the sale on your absolute dream home.
Oh man, best feeling in the world, right?
Totally. The boxes are packed, the moving truck is booked, you're ready. And suddenly, your buyer's mortgage lender calls to say, they're pulling the funding entirely.
It's just a total nightmare scenario.
Exactly. And why? Because the previous owner decided to, save $100 on a weekend DIY wiring project in the garage like 5 years ago.
Yep, happens all the time.
And now there is no official paperwork proving it won't just burn the house down. It is a nightmare, but it's completely avoidable.
Oh, 100% avoidable.
So today, our mission for this deep dive is to make sure you never find yourself in that position. We are cutting through the invisible red tape hidden behind your drywall.
Getting into the good stuff.
Right. We're looking at the crucial differences between electrical permits and electrical inspections, how they actually work together to keep you safe, and why bypassing them is just a profound mistake.
Yeah, a really expensive mistake.
For sure. And we're pulling our insights today directly from Copperfield Electric's resources, specifically their April 2026 guide on navigating local building codes.
Which is an incredibly detailed guide, by the way.
It really is. Okay, let's unpack this. Because whether you are gearing up for a massive kitchen remodel, installing a car charger, or you are just insanely curious about how the built world stays safe, this is your roadmap.
And it is a roadmap you are absolutely going to need. Because, well, the way we consume electricity in our homes right now is undergoing a massive fundamental shift.
Right.
The infrastructure humming behind your paint simply wasn't designed for the load we are suddenly throwing at it.
Yeah, let's talk about the sheer scale of modern electrical projects for a second, just to understand why this oversight even matters.
Sure.
Because we aren't just talking about plugging in a new blender anymore. Look at a company like Copperfield Electric, right?
That's a great example.
They are a family-owned 24-hour electrical contractor serving Orange County in Southern California. We're talking Irvine, Anaheim, Santa Ana, Costa Mesa.
Newport Beach, too, yeah.
Exactly, Newport Beach. And the range of what they handle daily perfectly illustrates how complex our power needs have become. I mean, they do residential and commercial work, emergency and standby power generators.
Oh, generators are huge right now.
Right, and they do total new construction wiring for things like ADUs.
Which, for anyone unfamiliar, stands for accessory dwelling units.
Like a guest house.
Yeah, exactly. Think of a fully functional guest house or maybe an apartment built over a garage. It requires an entirely separate, comprehensive electrical ecosystem that's tied into the main property.
Which sounds incredibly complicated.
It is.
And then, there's the massive trend of electric vehicles, or EVs. I know Copperfield does a ton of panel replacements and upgrades specifically for EV charging.
Oh, yeah, constantly.
And it seems like a lot of folks assume plugging in a car is basically the same as plugging in a really big television.
Yeah, and that is a very dangerous misconception. You really have to understand the physics of what is actually happening behind the wall. An electric vehicle charger isn't just drawing a little bit of power. It is pulling a massive, continuous electrical load for, 8, 10, or even 12 hours straight.
Wow, that long.
Yeah. Think about a microwave. It uses a lot of power, but only for 2 minutes at a time.
Just to heat up some leftovers.
Exactly. So the wires get a tiny bit warm, and then they cool down. But an EV charger is running that equivalent heavy load all night long.
Oh, I see.
Yeah, and if your home's electrical panel isn't rated for that capacity, or if the wiring itself isn't thick enough to handle the current, the physical resistance inside those wires generates heat.
Which sounds bad.
It's very bad.
Yeah.
Continuous heat. Eventually, the plastic insulation around the wire literally melts, the exposed copper arcs, and suddenly you have a fire inside your walls.
That is terrifying. Just completely terrifying.
It really is.
And on top of all that heavy residential work, Copperfield handles high-voltage commercial distribution for, warehouses, healthcare facilities, even elevators.
Serious infrastructure.
Right. So they clearly have highly trained, background-checked, licensed, and insured technicians. They even offer a 100% satisfaction guarantee.
Yep.
So here's what I don't understand. If you hire a deeply experienced 2047 professional team like that, why does the city government need to get involved at all?
That's the big question.
I mean, isn't their state license and their company guarantee proof enough that they know what they are doing?
This raises an important question, and honestly, it is the absolute most common point of friction for anyone looking to upgrade their home. Why do we need the city looking over a professional's shoulder?
Right, it feels redundant.
It does feel that way. But the answer is that a contractor's license proves their capability to do the math and handle the tools safely.
Okay.
But local building codes are the absolute law of the land, and those laws are incredibly hyper-local.
Hyperlocal, meaning like the soil or the weather in Newport Beach might require different safety protocols than a neighborhood in Anaheim.
Precisely. Coastal cities deal with heavy salt air that accelerates corrosion in outdoor panels, right?
Oh, I didn't even think of the salt air.
Yeah. And inland areas might have totally different grid capacities or deal with extreme heat that affects how wires are rated to dissipate thermal energy.
That makes a lot of sense.
So the city's oversight ensures that the specific work being proposed adheres to the hyperlocal laws designed to protect your specific community.
So the contractor does the heavy lifting, but the local authority provides the standardized safety framework.
Exactly. It's a partnership, really.
Well, that framework relies on a two-part system to actually enforce those safety rules.
Yeah.
Because obviously you can't inspect the work if the city doesn't know the work is happening in the first place.
Nope. They have to know about it.
So the very first hurdle in this whole process is getting the electrical permit.
Which is critical.
Right. This is the official legal approval from your local authority before a single tool is lifted.
And the timing is crucial there, before any work begins.
Got it.
It is your literal permission slip from the city, confirming that what you want to do is legal and safe.
And you need one for pretty much any major alteration, right?
Yeah, generally speaking. Panel upgrades, running new circuits, installing those EV chargers we talked about, or major remodels.
But what if I'm just swapping a light switch?
Oh, if you are just swapping out a broken light switch for a new one, you typically don't need a permit.
Okay, good.
Though it never hurts to verify with your local building department just in case. But for heavy structural changes, it is absolutely mandatory.
Here's where it gets really interesting. The permit is not just a receipt you buy at City Hall to appease the taxman, right?
Not at all.
It actually triggers something called a plan check phase. And I've been trying to visualize how this works. It reminds me of a civil engineer designing a massive highway interchange.
I like that analogy.
Right, because you wouldn't just pave a road and start routing 10,000 semi-trucks down a one-lane residential street.
No, you'd destroy the road.
It would cause an immediate catastrophic traffic jam. You have to calculate the volume of traffic, the load limits of the bridges, the merge lanes, all of it on paper first.
That is a phenomenal way to look at it, because electricity behaves very much like traffic flowing down a highway or, water flowing through pipes.
Well, there's an analogy, yeah.
Right. So during the plan check phase of a permit, city engineers are reviewing your highway design, your project plans, before you spend a single dime on copper wire.
So they're checking the math.
Exactly. They're checking load calculations to make sure you aren't routing semi-truck levels of electrical current down a wire only meant to handle a table lamp.
Because if you do, that is when we get that thermal breakdown and melting insulation you mentioned earlier.
Without a doubt. The plan check ensures you have the right wire sizing, proper grounding systems, adequate clearance around the electrical panel.
It's all verified up front.
Yes. It is the ultimate enforcement of the measure twice, cut once philosophy, and it's mandated by law.
So it protects you from incredibly expensive mistakes. I mean, imagine buying a $2,000 EV charger, hiring a guy to pull the wire across your entire house, only to realize your main service line physically cannot provide enough amperage.
Oh, you would have a perfectly installed, totally useless piece of equipment. Or worse, a dangerously overloaded main breaker.
No, that's bad.
Very. The permit ensures the design is inherently safe and feasible from step one.
Okay, so the city engineers love our highway design. They stamp the permit, they give us the green light. But paper doesn't conduct electricity.
True.
How does the city actually know the guy we hired didn't cut corners, use cheaper materials, or just get sloppy once he started pulling wire through the attic?
Enter the electrical inspection.
The reality check.
Exactly. This is the reality check. Once the theory is approved via the permit, the inspection is how the city verifies the physical execution actually matches that theory.
Okay.
A certified, independent inspector from the municipality comes out to your property to physically examine the work.
And for major projects, this isn't just one quick visit at the very end, right?
No, not usually.
There are two distinct phases, the rough inspection and the final inspection. And I have to admit, the final inspection makes complete sense to me.
Sure, work's done. Check the work.
Exactly. The work is done. Come test the system. Give me the final sign-off. But pausing your entire renovation, leaving your walls completely open and exposed, just to wait for an inspector to come look at bare wires during the rough inspection.
It sounds annoying.
It sounds incredibly frustrating. Why can't they just take a multimeter, one of those little handheld diagnostic devices, plug it into the outlet at the very end of the job, and confirm the power flow safely?
What's fascinating here is that exact frustration stems from a very common misunderstanding of how electricity actually threatens a home.
Okay, how so?
Well, testing an outlet with a multimeter at the end of a job only tells you one thing: continuity.
Meaning the power is there.
Right. It tells you the circuit is complete and voltage is present. It tells you absolutely nothing about the hidden dangers lurking in the spaces behind your drywall, under your floors, or buried in your attic insulation.
Because the device can't tell how the electricity is getting there, just that it arrived.
Precisely. Let's go back to our physics. Say the contractor used a wire gauge that was slightly too small.
Like the EV charger example.
Exactly. A multimeter will still read 120 volts at the outlet. It looks totally fine. But behind the wall, that wire is getting hotter and hotter every time you plug in a vacuum cleaner.
Wow.
Or consider how the wire is routed. If the cable isn't secured properly to the wooden studs using staples at specific intervals, it can sag.
Just from gravity?
Gravity, yeah. And over the years, the slight vibrations from doors slamming or plumbing pipes rattling can cause that loose wire to chafe against a sharp nail.
Oh, man.
The insulation wears away, the bare copper touches the nail, and suddenly your wooden house frame is part of an electrical circuit.
That is wild. And you wouldn't know any of that was happening until smoke started pouring out of the air vents.
You'd have no idea, which is why the rough inspection is your absolute last line of defense against those silent hazards.
They need to see the guts of the system.
Yes. The inspector needs to see the literal skeleton of the electrical system. They examine the box volumes to make sure wires aren't crammed so tightly they create a heat sink. They verify the physical routing. Once the drywall goes up, all the evidence of shoddy workmanship is literally walled off for the next 50 years.
That changes the perspective entirely.
Yeah.
It isn't a delay at all. It is a life-saving audit of the most dangerous infrastructure in your home.
Exactly. And then, once you pass that rough check, you put up the drywall, paint the room, install your switches and faceplates.
And that triggers the final inspection.
Right. The inspector returns to check the visible finishing work. They might test specific safety mechanisms like ground fault protection near your kitchen sink.
That's the system that instantly cuts power if electricity starts flowing through water instead of the wire, right?
Yep, the GFCI outlets. So if everything operates as intended, you receive your final approval.
So we have this highly integrated two-part safety net. The permit verifies the theoretical design, and the inspections verify the physical reality.
Locked together.
They are locked together, which brings up the elephant in the room. What actually happens if you just decide to bypass all of this?
Oh, boy.
Say you want to save a few $100s on city fees, so you just hire a buddy who, quote-unquote, knows electricity to throw a new 240-volt breaker in the panel for a welder in the garage. Totally under the radar.
Yeah, people do it.
What is the real-world fallout of trying to game the system like that?
It is the ultimate false economy. People think they are pulling a fast one on the bureaucracy, but the consequences are swift, severe, and incredibly expensive.
What's the first thing that happens?
Well, first, if the city finds out you were doing unpermitted work, maybe a neighbor complains about the construction noise, or a city worker just drives by and sees an unpermitted trench in your yard, they will issue an immediate stop work order.
Oh, wow. So that halts your entire project in its tracks.
Completely halts it. And you will face heavy financial fines and penalties from the city. But the truly devastating part, the city can legally force you to tear out the completed work entirely at your own expense because they have no way of verifying it was done safely.
That is brutal. You literally have to destroy what you just paid to build.
Yep. And remember, by skipping the permit, you inherently skip the rough inspection. You have willfully introduced an unvetted, profound fire risk into the building where you and your family sleep every night.
Okay, let's play devil's advocate for a second.
Okay, let's do it.
Let's say your buddy actually did a phenomenal job. It is totally safe, the welder works great, the house doesn't catch on fire, and the city never notices.
Okay, lucky you.
Right. But fast forward 5, maybe 10 years.
Yeah.
You decide to sell the property. This goes back to that nightmare scenario I mentioned at the very beginning of the show.
The real estate trap.
Yes.
Yeah.
How does unpermitted work blow up a real estate transaction?
It creates a massive cascading failure during escrow. When you put the house on the market, the prospective buyer is going to hire an independent home inspector, right?
Standard procedure.
Right. That inspector is going to open your electrical panel, look at the city's public records for your property, and instantly see that there is a massive 240-volt circuit running to the garage that has absolutely no paper trail.
So they flag it in the inspection report.
Immediately. And that report goes directly to the buyer's mortgage lender.
And lenders hate risk.
Banks are highly risk-averse. Many lenders will outright refuse to fund a loan on a property with unpermitted electrical work because they view it as a liability that could just burn their collateral to the ground.
And what about insurance?
Oh, the homeowner's insurance company might threaten to drop coverage on the property for the exact same reason.
So the buyer walks away, your sale collapses, and you are stuck with the house.
Exactly. To save the sale, the seller usually has to go back to the city, confess to the unpermitted work, pay massive retroactive penalty fees, and then hire a licensed contractor.
Like the professionals at Copperfield Electric.
Like Copperfield, yeah. You have to hire them to tear open the drywall, inspect the hidden wires, bring everything up to modern code, and get it legally permitted after the fact.
So what does this all mean? It means you end up spending exponentially more money, time, and stress than if you had just followed the rules in the first place.
Nope, it's a huge headache.
Not to mention, fully permitted, approved homes sell faster and at a premium because buyers have confidence in the infrastructure.
Yeah.
You are literally protecting the financial value of your biggest asset by playing by the rules.
If we connect this to the bigger picture, you have to realize that building codes are not arbitrary hoops designed to annoy you.
Right.
They are written in blood and ash.
That's a heavy way to put it, but it's true.
It is true. Every single regulation in the electrical code book, from how deep you have to bury an outdoor cable to the exact volume of a junction box, exists because somewhere in history, the absence of that rule led to a catastrophic failure, a fire, or a loss of life.
The code book is a living document of hard-learned lessons.
Exactly. When you follow the process, you aren't just filing paperwork. You are inheriting a century of safety engineering.
Wow. You are guaranteeing local compliance, avoiding penalties, and maximizing your property value. But above all else, you are securing absolute peace of mind.
Peace of mind is priceless.
It really is. You sit in your living room, the air conditioning is blasting, your electric vehicle is silently charging in the garage, your family's asleep upstairs, and you never have to wonder if the hidden wires behind your walls are slowly melting.
Exactly.
We've completely reframed how to look at this bureaucracy. The permit is your blueprint, the theoretical permission to build safely.
Right.
And the inspection, both rough and final, is the reality check that proves the execution is flawless. They are a single, continuous lifeline protecting your home.
And when you rely on local licensed experts like the crew at Copperfield Electric, they handle this entire bureaucratic dance for you.
Which is huge.
Oh, it's massive. They pull the permits, they schedule the inspections, ensure the work is perfect, and just hand you a modern, safe system.
It is a remarkable ecosystem of trust and verification when you step back and look at it.
It really is. And, it leaves me with a thought that is kind of hard to shake. Yeah. We trust our lives every single day to invisible systems buried behind drywall and concrete. We sleep soundly, relying entirely on the integrity of the tradespeople who installed those systems and the rigor of the municipal inspectors who verified them.
That's true. We never really think about it.
Right. It begs the question, what other hidden rough inspections in our daily lives, from the millions of lines of code operating our banking software to the unglamorous stress tests on the airplanes we fly, are quietly keeping society running without us ever noticing?
Oh, man. That is going to keep me thinking all day. The invisible safety nets everywhere.
They're everywhere.
Well, thank you for joining us on this deep dive. Keep asking questions, keep looking behind the drywall, and we'll see you next time.